All right. It's a beautiful evening. How you guys doing? Hope you enjoyed the Saturday. And how was your day? Um, so yesterday, we started our class on complex number, and I'm sure you guys were able to follow through on what we did. I gave some exercises for you to work on, and I would love to get your feedback on how it went. Hope you enjoyed it. Hope you were able to get through with it. Okay. You guys said your day was fine. That's nice. That's good to hear. Somebody said it wasn't fine. What's up? What happened? Okay, you've done it. That's nice. That's good to hear. So, I believe the question I asked you was centered around finding the multiplicative inverse. So, were you able to get the multiplicative inverse of the three different exercise I gave you? Were you able to get the multiplicative inverse? And then I also told you to make a particular operation, which was for you to add and subtract sets of complex numbers. Okay, since you guys are giving me a positive feedback, were you able to solve it? Did it go well? Was there any issue? Can I get some feedback? Anybody had any issue in solving what we had yesterday? Or were you able to get it through? Can I get any feedback on that? Okay, you guys were able to solve it. Okay. All right. In this class, I want to go into something very vital. So yesterday was very important. I laid the basics of complex number, and I explained to you the importance of those basic concepts in mathematics, because when you have the basics done, you don't have issues anymore. So in this particular class, I want to get into something much deeper that has to do with complex numbers. So please pay full attention, take your notes, and you can walk through with me as soon as I give you an exercise. Now, I'm sure you have always seen, especially in your previous test, you saw things that has to do with high, where you were told to find I raised to power something, I raised to power minus something. So in this particular class, I want to start with the power of I. Just as a revision yesterday, I explained to you the quadratic expression that gave birth to the concept of complex number. And that was when you have something like x squared plus 1 equals to 0. And we said we had x squared equals to minus 1. If you are going to take the square root, x is going to be equals to square root of minus 1. And we can't find square root of minus 1. That was why we had to introduce something where we said hi being equals to minus 1. I explained all this concept, and I'm sure you understand. We said we should represent our high to be square root of minus 1, and that made us to conclude that I square will be equals to minus 1. So, and then we went on to talk about the basic operations, then we talked about the multiplicative inverse and so on. But now we want to delve into the power of I. So we want to explain everything that has to do with you having I raised to power anything. It could be 400 raised to I raised to power 431, I raised to power 56, I raised to power any power. How do you make your conclusion on all these questions? So we have to start from the known and then move to the unknown. All right. So let's start from the known. The known is the high square. I believe from the class we had yesterday, everyone understand that I square equals to minus 1. This is basic. This is not something that anybody right here should struggle with if you attended the class yesterday. And if you did not attend the class yesterday, you should understand that I square equals to minus 1. You can see it right there. Just note that. Now let's move on to let's try and scale this I square to different powers. Please pay attention because I'm sure some of you are having issues in this particular aspect. So please pay attention to all we'll be doing. Now, if you go on to, let's assume we want to do for I cube. That's the next power after I square. So let's try and do for I cube, I raised to power 3, which is the next one after I square. All right. I cube. I'm sure nobody here denies the fact that it is okay for me to write I cube as I square multiplied by I. I'm sure nobody is here saying I'm doing something strange. I square times I is same thing as I cube. All right. Now look at what we said here. I square equals to minus 1. So it's okay for me to still go on to write minus 1 multiplied by I. I'm sure you guys are flowing with me. I've not done anything that is strange. All I did was change my I square to minus 1 since I knew that I square was minus 1. So you can see right here, my I cube now, I can conclude it to be equals to minus I. That is the very first one we will be doing. So I cube is minus I. Now let's go on to do for I raised to power 4. We'll do for this to I raised to power 7. So you know one thing I can ask you to try and do? While I'm explaining mine, you can go on to try for I4, I5, I6, I7. We're going to stop at I7. And from that, we're going to make a conclusion on every other possible positive power of I. All right. So let's see I raised to power 4. I raised to power 4 will obviously be what? I square times I square. All right. I'm sure nobody disagrees with me. Now, if it's I square times I square, now that means I would not be wrong if I wrote this as minus 1 being the first I square times minus 1 being the second I square. So that means minus 1 times minus 1 will obviously be positive 1. All right, that means we can conclude that I raised to power 4 is equals to plus 1. You can see it right in front of us. Now let's try and solve for I raised to power 5. What will be I raised to power 5? I'm sure you know I raised to power 5 will be equals to I raised to power 4 times I. I'm sure you don't disagree with this. And I raised to power 4, you can actually just pick this, or you can decide to still break it down as I raised to power 2 raised to power 2. Whichever one will work, you get the same answer. So this will be I raised to power 2 raised to power 2. That's I4 multiplied by I. Now what is I raised to power 2? I raised to power 2 is equals to minus 1. That's minus 1 square multiplied by I. Obviously, minus 1 square is 1. This will be 1 times I. So finally, this will give me my value to be I. So you can see how just by using the initial I square equals to minus 1, you can see I've been able to derive, when you are dealing with all these things, please start from the known to the unknown. I've been able to define I square, I cube, I4, I5. Now, let me try and do for I6. I6, of course, will be I raised to power 5. Or you can do it as I raised to power 2 cube raised to power 3. That's still also permitted. Because I'm sure the law of indices, you guys know that this I raised to power 2 all cube is the same thing as I raised to power 6. And if you know your I squared to be minus 1, that will be minus 1 raised to power 3. I squared is minus 1, so minus 1 raised to power 3. When you have a negative number raised to power an odd number, you will always get a negative number. This is minus 1. I'm sure you guys can note all this. Now let's do for the last but not the least. We have I raised to power 7. What should be I raised to power 7? I raised to power 7, of course, will be I raised to power 2 raised to power 3. That will be like I6. You can have it as I6 multiplied by I. and I6 is I raised to power 2 raised to power 3 multiplied by I. So you can see, of course, you can just go on to lift I6. All these are just me. I'm just trying to break it down much more smaller. You can easily just go on to fix I, because I'm trying to make everything on the basis of I square. Because the reason why it's good for me to use I square as the basics is because if you are in an exam hall, it is possible you may not have I6 handy. That means you don't have I6, the value for I6. So if I go on to just be filling this with I6, some people that may not be able to understand what I'm doing may find it confusing. That's why I have to use I square all through, so that at least you can only ensure you remember I square equals to -1. And from I square equals to -1, you can get every other value. So you see now that instead of writing I6 equals to -1, I went on to break it down to I square raised to power 3. And what is I square? I square is -1. That will be -1 raised to power 3 multiplied by I. This will be -1 multiplied by I. And this will give me the value of -I. All right, this makes sense. Now, it is on this basis we are going to be able to define any other one. We now want to make a general conclusion now. And I would love you to take note of this general conclusion, because you may not always want to tear everything down this way when you are dealing with a time-based exam. So let's make a general conclusion of all what we can have here. Now look at what we have here. When we have I squared, we already know that was equals to -1. But what about us making a conclusion as regards all this, rather than us having to always solve this one after the other? So if you have, let's take k as an integer value. For integer k, or any integer k, look at this conclusion I want to make now. When I have I raised to power 4k, that means if k was 1 now, that means the meaning of integer k means multiples of 4. If 4k now means this 4k will always be a multiple of 4. So if k was 1, that will be 4. If k was 2, that will be 8, and so on. So for every multiple of 4 as the power of I, look at it right here. You can see when we had I raised to power 4, what we got was 1. So we're going to make a general conclusion that whenever we have the multiple of 4 as the power of I, our answer will always be 1. Now the next one, you can see we can make for, what about when we don't have a multiple of 4, but we have a multiple of 4 plus 1, like that of I5. You can see I5, I raised to power 5 is the same thing as I raised to power 4 plus 1. I'm sure you understand that. So I can go on to make a general conclusion and say if we have I raised to power 4k, that means any multiple of 4 plus 1, like in this case, that's I raised to power 5 is a perfect example for this. All I need to do is to go on to pick whatever my high 5 was. So I can conclude that every multiple of 4 plus 1 will give me my answer to be high. These are some of the things you get from this general solving we just did. So, and if you go on to, let's check for that of when a multiple of 4 was added with 2. So that a scenario for that would be I raised to power 6, because you know that I raised to power 6 is equals to I raised to power 4 plus 2. So I raised to power 6 is a perfect example of a situation like this. So we just conclude that that will always be -1. You can see from I raised to power 6 right here. And the last but not the least is when we have I raised to power 7, which was I raised to power 4 plus 3. When we have the multiple of 4 added with 3, I raised to power 4k plus 3. So we'll go on to 7 is a perfect, I raised to power 7 is a perfect example for that, and that will be -I. So these are general conclusions we make based on the power of I. The reason why I would advise you to take note of all this is because when you get to an exam hall, you want to use all this quickly. You may have a much bigger number, you can pick, for instance, let's say we are dealing with I raised to power 431. That's a number. I've not done that. Let's try and do that together now. Let's say we have I raised to power 431 now, and we're told to solve this. You know it's going to be very hard for you to make use of all these ones if you're not very good mathematically, and that's why it's good for you to just note this. That first of all, go and address it being a multiple of 4 first. So one of the first things we ask you to do, for everyone listening to me, if you have any power of I, not negative by the way, this is, don't forget, all these are all positive powers. We'll talk about the negative power very soon. So if you have I raised to power any positive power, the first thing you should do is try to do that number divided by 4. So you just pick a calculator and say, in this case now, 431 divided by 4. You want to identify the situation going on with 431. 431 divided by 4, you got, look at what I got when I did 431 divided by 4. I got 107.75. All right. So you know what I'm going to do now. Now that I got 107.75, I know already that I have a perfect 107. But this 0.75 wasn't a perfect factor of 4. So obviously, this decimal place is the remnant, which was not which 4 could not go in. So I go and pick this 107. I'm teaching you how to use your calculator to get this done. So go and do 107 times 4. What's 107 times 4? 107 times 4 is 428. So I know that this I raised to power 431 is 107, is 4 times 107 plus, because I don't know, to find out the plus, whatever was added. 107 times 4, I got 428. Now, 428, how much is left to get to 431? We have 431. 431 minus 428. That's 3 left. So you can see that I can write I raised to power 431 as 4 times 107 plus 3. You see how fast this is. So now that I've done this, I already know the section it falls in. This is obviously that of course in this case now K was 107. K could be any integer, as I said already. K was 107 here. This is the perfect example. That for this one is a perfect example of this particular scenario. So obviously, I raised to power 431. I don't need to be going on to crack my head and rack my brain on all this. I just need to go on to write minus I. All right. You can see how to solve this. You don't have to you don't have to ever miss any question on this again. So let me just give you random numbers, and you will tell me whatever the answer is. I raised to power 729. I raised to power 729. Can you do that quickly? Let's perfect this and be sure that nobody is. I raised to power 729. I want you to be very sound in this, so you could never miss anything on this anymore. I believe I'm permitted to rub this place up because we have already concluded on our general syntaxes for complex numbers. Let me just leave those ones. So I raised to power 729. What's your value? What does it fall in? Okay, people are giving me the answer as high. Please, I hope everybody in this class is following, because when I do I raised to power 729, I went on to do 729 divided by 4. I got 182.25. So obviously, I go back, I know this is I raised to power 4 times 182 plus, but I don't know whatever the plus is. So I go on to do 4 times 182. 4 times 182, that's 728. 728, that means I was left with 1 to get to 729. So this is obviously the scenario, that of this. So I just write I as my answer. Is it making good sense to you guys? This is how simple this thing is. You should never miss any question on it anymore. So because of time, we may not be able to spend so much time trying to explain more on that. You can go and just give yourself Let me give you this one I saw here. Can you do I raised to power 9 plus I raised to power 19? Just do that very quickly. Let me see your answer. So you can go on to solve several questions on this. It's still the same strategy. So can you go on to solve that quickly? I want to go to the next aspect. Just tell me what your answer is there. Nobody should fail any question on complex number after these classes, please. This is the reason why we're here, for sound understanding. Oh, people are getting different answers. What is I raised to power 9? What is I raised to power 9? I raised to power 9 is obviously I raised to power 4 times 2 plus 1. That's 8 plus 1. And that's this scenario. That's I. So I know I raised to power 9 is equals to I because it falls under this category. What's I raised to power 19? I raised to power 19 will be I raised to power 4 times what now? 4 times 4. Is it 4 times 4? No, 4 times 5. Is it? It's 4 times 4. 4 times 5. What's 4 times 5? 4 times 5 is 20. So it's actually 4 times 4. That's 16. So 16 plus 3. That's 16 plus 3. That's 19. So that's this scenario. Minus I. So that is equals to I plus minus I. You guys are geniuses. 0. That's perfect. I love that. 0 is the answer. So can you see how a question like this can come in an objective or probably even in theory? I raised to power 9 plus I raised to power 19. You see how in a very short time you are able to answer this question without racking your mind on anything. Because you just knew this syntax. So you can understand the importance of knowing this syntax. This will make your work so easy. If you want to derive it, I already explained how to derive it. And if you want to just cram this, I prefer you knowing how to get it and then probably cram it. It's all up to you. So let's go on to quickly talk about the negative powers, because that's also another aspect that you need to pay attention to. So please, we are still on the powers of I, but now we want to go into the negative powers. So you can have a question given that would feature actually both, where you have positive power and negative power. I love that you guys are flowing and you guys are getting it. That's the joy of teaching. So let's try and quickly explain how we got our negative powers. So let's just talk about these few I raised to power. We'll do for I raised to power minus 1. We'll do for I raised to power minus 2, I raised to power minus 3, and I raised to power minus 4. And when we're done with this, I'm sure you guys will be balanced enough to answer any question on negative powers of I. Now, if you are conversant with this aspect of mathematics, you know that when you have I raised to power something like this, we can go on to fill all this in. This would be 1 over I. This other one will be 1 over I squared. This one will be 1 over I cube. Let me shift this one a bit down. I raised to power 4. This will be 1 over I raised to power 4. All right, that's the first step. Nobody argues with this. Now, in mathematics, we call something rationalizing. You see, when you have some things as your denominator, it's not permitted. It's not something we accept in mathematics. So when you have, in this case, like you can see, this is a complex number. As the denominator of, normally, if it was permitted for us to have denominator as just anything, then all this will be the answers of these things. But because we don't agree for situations like surds or a complex number to be as the denominator, we have to do what we call rationalization. So, and how do we rationalize? In a case like this where it's just a simple number, all we have to do is to multiply by the denominator, whatever the denominator was. So we multiply by the denominator over the denominator. You know, rationalization doesn't change the what you are dealing with. So, you know, in mathematics, one principle you should always work with is that you should never change what you are solving. And that's why you see that we're doing I over I, because I over I basically is still 1. So it's more like we're saying 1 over I times 1 is still 1 over I. But we just want to change the form. That's all we're trying to do here. So if you look at this, you can notice that I can go on to make a conclusion that this will be 1 times I will be I over I times I square. I'm sure you agree with me that I square is equals to minus 1. You see the basics of complex number. You must never forget that I square is always minus 1. So this will be I over minus 1, which will be minus I. All right, that's the first one. So tomorrow when you are asked to solve I raised to power minus 1, always remember that the answer is minus 1. Can you go on to attempt for the remaining while I solve it here also? Look at this other one. What you have to do here is just push in the value of I squared. That'll be 1 over minus 1. That'll be minus 1. All right. That's how simple this is. You don't have to sweat over this. Now, what you have to do here when you have 1 over I raised to power 3. Now, can anybody remind me of what I raised to power 3 is? In case you have forgotten, and maybe you're in an exam hall and you have forgotten, all you need to remember is I cube was I squared times I. And that's minus 1 times I. So that's minus I. So obviously, I can go on to write this as 1 over minus I. I'm sure you all agree with me. Sorry, let me write this properly. So 1 over I cube is equals to 1 over minus I. So what you have to go on to do is to do what we call the rationalization. In this case, that will be times I over I. Whenever you have something like this, maybe I as a denominator, or in this case, you just rationalize to get your final answer. And when you have a case like maybe you have I squared, you go and find what's the value of I squared, you fix it there. What's the value of I cube, you fix it there. Then you can't leave it as 1 over minus I, so you have to rationalize again. So in this case now, you're having I over what? In this case now, this is I over minus I square. If you can look at it, this I times I, that's I square, and then there is a minus there. So that will be I over minus I square. I'm sure you guys can flow with that. So now, this is I over, what is I square? Minus 1, that will be minus 1. That will be I over 1. That will be I. So you can see how we solve all these things. Quite very simple. And let's do that of I raised to power 4. What is I raised to power 4 normally? We said I raised to power 4 was equal to I raised to power 2 square. So that will be minus 1 square. That's what? 1. So I don't need to do too much on this. This is 1 over 1, which is 1. All I did was, what was I raised to power 4? I raised to power 4 was 1. That's 1 over 1. That's 1. I'm sure it makes sense to you guys. This is how you solve questions on complex numbers. Very simple, am I right? So let me give you a question quickly. Can you quickly find I raised to power 35? I raised to power minus 35 rather. I raised to power minus 35. Can you solve that question quickly? I raised to power minus 35. What's the answer? I raised to power minus 35. What is I raised to power minus 35? Okay, people are, is the answer high for the question I'm asking? Okay, different people are having I, someone is having a minus I. Okay, let's see I raised to power 35. So the question is, what is I raised to power 35? Now you go back to try and solve what is I raised to power 35 normally. I raised to power 35 is I raised to power, don't forget that principle. 4 times what is this? 4 times 8 plus 32 plus 3. This is something I just explained, so don't try. And this is something I just explained. So this is what was I raised power? What was this scenario equals to? That's why I say you have to cram it. This scenario was equals to what? When you have the plus 3, what was it equals to? Minus I. Obviously, this is equals to 1 over. I just went on to solve for I raised power 35. I got minus I because I raised power 35 conformed with the scenario where we had plus 3, which is minus I. So this is 1 over minus I. So you have to go on to rationalize this. That will be I over I. That will be I over minus I squared. All right. This will be I over minus, then minus 1. This will be I over 1. This will be I. Yeah, I love what I'm seeing. I love what I'm seeing. I love who is that talking about Valentine? Have you known calculus? Have you known complex numbers so well? Anyway, same wishes to you. And I hope you spread love towards your book, also towards your studies, and get the best in the exam. So I don't know if we need to solve more questions around this. I'm feeling I have been able to communicate this perfectly. You guys can give me some feedback if you're having some issues around this. So I can, or do I move on? What's your present understanding of this? Do I move on? Okay, let me give you one more. Probably you do I raised power minus 333. Let's see this one. Minus 333. Try and solve that. Let me see. This will be the last question on the power of I, so that at least I'm sure you guys are perfect. That's what I just want to know. I want to know that you are good. So just give me the answer for I raised power minus 333. I may not solve that on the board. Just let me see your. I love what I'm seeing. Some people are really flowing. Please, if you're on this chat, or if you're in this on this live stream, please, I want you to give me feedbacks. I love what I'm seeing. Some people have gotten the answer already. Please make sure you are solving it. Make sure you are trying it so that you can be perfect in this. No more stuttering around this anymore. So I want to run quickly to certain things. Okay, I need to still explain something because I don't want you to ever get confused. Somebody got I. Is it high or minus I? Please confirm that. I may not be able to solve that question because of time. I want to go into something else very quickly. Is everybody on the same page as minus I? Someone is getting high. Do you want me to do it? People are getting high. Okay, it looks like majority are getting minus I. Okay, so I want to give you another very important aspect of complex number. If we can't finish it today, we'll complete it tomorrow, and we'll talk about some other. So I don't want to focus on speed too much here because of I want everyone to be very perfect in this topic. So please, let's pay attention to the square root of a negative real number. The square root of a negative real number. That's the subtopic we're dealing with now. The square root of a negative real number. The square root of a negative real number. So I'm sure we did a bit of this yesterday, but you'll be seeing a different dimension to this and why we need to talk about this. So if I ask you guys, what is the square root of minus 1? What is the square root of minus 1? What is the square root of minus 1? What's going to be your answer? The square root of minus 1. Square root of minus 1 is what? Let me look at the answers I'm hearing. Someone says hi. Okay, many people are saying I. Okay. Now, what if I told you that there are two answers? There are two answers to the square root of minus 1. And this is why. The square root of minus 1 is actually I and minus I. And I'll tell you why. Look at it. If you said I square was equals to minus 1, I'm sure you all agree with this. This is something we have always used in this class. So I square, the square root of the I square is equals to minus 1. So if you go on to try and find the square root of this, that's what brought about I being equals to minus I. Now, but what if you look at this also? What is minus I square? What is minus I square? It is from this you arrived at the positive aspect. But let's see what's minus I square. Minus I square will be equals to, of course, I square, which will be equals to minus 1. Now, pay attention to what I want to show you. Look at something. We said I square equals to minus 1. You agree with that? I now went on to say, okay, what about minus I square? Is minus I square not also minus 1? Of course it is. So look at these things. If I go on to find the square root of both sides, let me write that on this side so that in case, just to hasten understanding. So I'm sure you agree with me now that I square equals to minus 1, and you also agree with me that minus I square is also minus 1. So if you go on to take the square root of all this, you can see that square root of minus 1, because if you know what this will give you, square root of minus 1 here, square root of minus 1 here will give you I. Square root of minus 1 will give you I. And in this place, square root of minus 1 will give you, when this cancels this, will give you minus I. So that's what makes us to conclude that the square root of minus 1 is actually I and minus I. All these little things we're talking about, the reason why we have to talk about them is because it will give you perfect understanding of every question. So this is why we're going to conclude that square root of minus 1 is both I and minus I. Now, let's bring a general understanding of this now, which is the key. You will know why you're really going to need this. Just give me a few minutes to prove it to you why you will need to know what I'm explaining for on the board. You will see a situation where you would need to understand the square root of the negative real number. It's part of the questions that could be examined. Now let's go on to, I want to make a conclusion around the square root of any negative real number. Of course, minus 1 is one of the is one of the negative real numbers we are talking about, but it doesn't have to be only minus 1. We can have square root of minus 2. So I want to conclude on what will be square root of minus 2, what will be square root of minus 2, what will be square root of minus 3, what will be square root of minus 5, what will be the square root of minus 9, and so on and so forth. That's what I'm trying to do for you. So that wherever you see in any question that they gave you square root of something, you would know what you're supposed to use. That's what I'm trying to do right now. So now, let's try and do the same we did here for, let's say we have square root of 3 high. Square root of 3 high. Let's try for square root of 3. Let's see what we want to find, what square root of minus 3 will be. So of course you can do the same thing for minus 2. It's going to work. This is just a peak. So we can still go on to do for minus 2. It's the same thing. So let's say we have square root of 3i. If you go on to take the square of this, what will it give you? Can somebody give me my answer? What will be the answer of this? Square root of 3 I square, square root of 3I, then everything all square. Of course, for those of you that are following, you would see that this is the same thing as square root of 3 square, then I square. And then this will obviously be what? 3 times I square will be minus 1. That will be minus 3. I'm sure you all agree with me. Minus 3. All right. Now, can you go on? Can you go on to do for this also? Do for this. Minus square root of 3I square. What does this give you also? Minus square root of 3. Minus square root of 3 all square. Of course, if you go on to do this, this will be, you know how to do all this. This will be minus square root of 3. You put this in a square, then I square. This will obviously be what? 3, because you know square, we cancel the minus. It will be 3 I square. I square will be minus 1. It's also minus 3. Now, the same way I isolate, the same way I did for when I was dealing with 1. Now, we can conclude now. I'm sure nobody here argues with me if I decide to say, this is me just giving you the bedrock of the whole thing. So if I go on to put square root of 3I all square, and I say it's equals to minus 3, nobody argues that with me. And nobody will also argue if I say square root of minus square root of 3 all square equals to minus 3. Nobody argues with me. Good. Now, look at where my conclusion is coming on now. Don't forget I'm trying to find the square root of a negative real number. So, because from these expressions, these two expressions I have here, I've been able to bring out that square root of 3I square equals to minus 3. So, I want to now try and solve the square root of minus 3. And let's get it from here. So, I take the square root of both sides. Square root of this side. And I also take the square root of this side. I do the same thing for this. I'm sure you can all follow. So if you do this now, of course, you know that the square here, we cancel the square root. So I'm good to make my conclusion that I would not be wrong if I make my conclusion that the square root of minus 3, which you can see here, is equals to square root of 3I. And also the square root of minus 3 is equals to minus square root of 3I. I'm not wrong if I make these two conclusions from what I just did, because you know that this square, we cancel this. You will know the reason why I'm doing all these things very soon. So from what we did right now, you can see that I've been able to conclude that the square root of minus 3 is equals to what? Square root of 3I. Now, remember when we were doing that of I, we said square root of minus 1 from here was equals to I and minus I, because square root of minus 1 is also equals to minus I here. If you do for the one we did now for square root of minus 3, you can see we got square root of 3I and minus square root of 3I. Now, if you go on to do for square root of 2, that means you can go on to examine for square root of 2. Because of time, we may not do it. But you can go on to try and find the same, just follow the same pattern we did here. That means all you have to do if we wanted to do for 2, let's even try and do it. Imagine we just change this to 2. We change this to 2 now. Of course, this will change to 2. Of course, this will change to 2. And of course, this will also change to 2. If we change this one to 2, the same process, just following the same process, change this to 2 and change this to 2. That means we'll also be able to conclude that, of course, we'll be able to bring it inside this place also, and this will become 2. This will also become 2. I'm just saying, if you wanted to do for this, will now be 2 also, and this will be 2. So that means if you follow the same pattern, you get that square root of minus 2 will be equals to square root of 2i and minus square root of 2i. If you can really follow what I'm saying here. Now, if you look at the pattern now, you can see that we are able to make a conclusion around this square root of negative real numbers. This thing is very key. We'll solve a question in some few minutes and you will know the reason why you need to know this thing. If you understand this, you will be able to solve any kind of question that comes around this. And that's why I want to take my time to explain the basics. Now, this means we can conclude now that if we have sorry, let me just try and fix it here. That if we have square root of a, of minus a rather, if we have square root of minus a, let me just clean this up. Our answer will be square root of ai. That's exactly what we're trying to do. So we just want you to have an understanding of, if I just wrote this for you, you may find it difficult to comprehend what's going on. Now, why would I say square root of minus a equals to square root of ai? That was why I came all the way to try to prove this for you, so that you'll be able to move through the process. All right. So we can make a conclusion on this, that square root of minus a is equals to what we have right there. Now let me throw a particular question to you that will give you your understanding of this. Now, in many cases when you are solving, we don't tend to make use of the negative part of this. More like, just like we always conclude that I equals to square root of minus 1. That means square root of minus 1 is equals to I. And even though we were able to prove that it's also minus I, but when we are trying to solve, we always make use of this, not minus I. So let me give you something to solve, and I would love to get your response. But before we do that, let me solve some myself, so that you people will not get too hooked along the way. So that's the conclusion. You can make sure you have this somewhere handy. Make sure you have this conclusion. You can, all these are the proof that establishes the fact that square root of minus a. The meaning of minus a here means minus any integer for any integer a being a positive real number. So a positive real number, my square root of minus a will always give you the square root of I times I, obviously. So let's look at some of the kind of questions that you could be examined on, where you will be asked to give something in a complex number form. To look at now, we're told to express the following in the form a plus bi. So one thing you people want to do for me now is to put, I want you to put everything I'll be writing right on the board in this form. So the first one is minus 5i 1 over 8i. Can you put this in this form quickly and tell me what your final answer is? Let's move very fast. Can you put this in this form? Okay, now if you look at what we have here, don't forget this form. I explained the whole division of this form. This is the real part of this complex number, while this is the imaginary part. Now, looking at these two, we don't seem to have any bit of real part here. So that will be defined as, sorry, we actually have imaginary here and imaginary here, but see what will happen when we decide to make the multiplication. So if we have minus 5 times 1 over 8, that will obviously be minus 5 over 8. And then we have I times the I, which is I squared. This will be minus 5 over 8. What is I squared? Minus 1. All right. If you don't know I squared is minus 1, you see, you would have wanted to be confused about what's going on here. Minus 5 times minus 1 will obviously give you minus 5 over 8. Now, don't forget, you were told to put it in this form. This is not in that form. So what you have to do is to try to conform this to this form. So this will be equals to minus 5 over 8 plus your b here is 0. So your imaginary part is 0 high. Sorry, 5 over 8 rather, sorry. 5 over 8 because there's a negative here. All right. So what can you try and attempt? Can you attempt this also? Let me see what happens. Minus I, 2I, and then you have minus 1 over 8I, everything raised to power 3. Can you attempt this? Make sure you conform this to this form. Conform this to this form, A plus B high. Conform this to that form, A plus B high. Okay, I'm waiting for your answers. I want to rub this first one off. Anybody with a final answer? Okay, now one thing you want to do here is to try and open this. This is the most complex bracket. So you can open these two brackets. This will obviously be minus 2, then I square. I'm sure you agree with that. This I times I squared and minus times 2. So then for this one, we have minus 1 over 8 cube, then I cube. So if you want to break it down in a more clearer way, you can obviously know that this would be minus 2 over, sorry, let me leave the over first because we want to, let's solve this. This I raised to power 2 is what? You know what, let's try and bring the two. You can do it anyhow you want to do. You don't have to follow my own procedure. I want to bring these two together. Let me bring this close to this. So this will be minus 1 over 8 times minus 1 over 8 times minus 1 over 8. Then we have I raised to power 2 times I raised to power 3. This means just being trying to be very, I'm trying to open it up, which is not very important. So this will obviously be 8 times 8 times 8 is what? I think 256 bar. So this will be minus 1. This will be, of course, this will be minus 2 times minus 1 over 256. Then times I raised to power 5. This will be 2. Sorry, is it 256? Okay, 512. Okay, 512. Okay, so 512. And this will be 2 over 512 multiplied by, we can have I raised to power 2 raised to power 2 times I. I'm acting like as if we don't know I raised to power 5 before. So what is this? Will be 1 over 256. Am I right about that? And that will be 1 over 256 multiplied by, this is I raised to power 2, that's minus 1 square times I. All right. So what do we have? I raised to power minus I raised to power 2. This will be 1 over 256 multiplied by, this will be 1 times I. So the answer obviously falls on 1 over 256 I. So this is, if you want to leave it in this one, this will be 0 plus 1 over 256 I. So how many of you guys we're able to, how many guys were able to flow with what we're doing? Does it make sense? How many people understood what we just did? Hope it wasn't confusing. I'm sure it wasn't confusing because it's quite simple. It's not complex at all. And by the way, you could go through a different pathway. That means you could decide to, in the case where I was bringing I raised power 2 with I raised power 3, you could decide to have, you may decide to push it as -1 in that case. So let's see this question. This is something I want everybody to attempt. Now that we have done all this, I want you to leave this in that form. I want you to leave 5 minus 3 I raised power 3 in that form now. 5 minus 3 I raised power 3 in that form. So or probably I give you that as an assignment so we can try and solve this one. And then let me give you one more question I will solve here. Just one more question. So you solve this one as an assignment, and then we would come back to, you give me the answer of this tomorrow. But there's one question I want you to go with before we end this class. And it uses up that thing I proved earlier, the square root of minus a being equals to, sorry, the square root of minus a, yes, being equals to square root of ai. So I want you to express this one in that form now, in that same form. So can you try and express this? Wait, are you guys trying to solve this one? Is that what you are giving the answer to as 27 high? No, that's not correct actually. So take your time to solve it. All right. No. 125 minus 27 high is not correct for that. 5 minus 3i cube is not that answer. Can you try and solve this? Try and solve this. Do this as this is your exercise. This one is your exercise. But I want you to attempt this right here. Attempt this right here. Can you look at this question? There's something I want to bring out. I want to bring out from this. That's the reason why I brought this question out. Can you look at this question? Look at something there. You're supposed to do this in this form. There's something I want you to see. Okay, because of time, I want to just tell you what you are supposed to do here. If you look at this question, for those of you that, if you look at this question, look at something here. Look at this particular value. You can see square root of -2. That's a perfect place where you would need to apply what I just explained, where I told you that square root of a negative real number is equals to square root of a high. So that's one of the places where you will need that for application. So for you to solve this, you need to just have, this will now turn to square root of 2i. Because you would have been saying, we don't have, this is not a complex. If you don't understand this concept, you would feel this wasn't a complex number because you are not seeing the high there. But actually, you can see the high is back here now. So you know what we're going to do? You guys are going to solve these two questions as your assignment. So this is what you're going to take home. And tomorrow, first thing first, we'll try and start from here. We'll try and give the solution to these two, then try to complete the other things we still have to complete on complex number. So guys, you can take your time to rest and charge up your phones for the all important class by 9 p.m. 9 p.m. class, very important. We are going to be solving lots of questions, conic sections, polynomials. possibly calculus, we're going to be solving by 9 p.m. So guys, thank you guys for joining. I hope you really understood more on complex number. I hope to see you by 9 p.m.